Now, the second diagram here, please, your eyes should be here. The electron will flow to the ground. You remove the charge, the earth, leaving the charging body, you remove the earth. Once you remove the earth and remove the charging body, you have charged the body positively. You have charged the body positively. So the first thing you should know, most times the proper question that normally comes out in JAMB is on if you want to charge a body positively. What is the first step? The first step is by bringing a negatively charged body near the body. Bring the opposite. Bring the opposite. Bring the opposite. I can remember in our own time when we wrote JAMB. By the JAMB, mbane the JAMB. Yane the seketa abro JAMB. Mbane the JAMB. Icho eme messy ni hige nwe. Inwe messy mu 260. Inwe ro 260 afa gapta and merit list messy. Kita unne nwe se 350, 38. Mmadụ nwere ike forge the result. Kita ka president I make we accept. All right. Now, assuming we have two bodies that are close to each other, I have two neutral bodies close to each other. One, body A, 1, 2, 3, 4, 5. Now I have the second body B. I have A, I have B. If I bring something like a positively charged body near them, can somebody tell me the charges that will form in A and B? If I have two bodies, why are you hitting the boy? The boy is police station. Police station. Now, please, can somebody answer? Can you tell us the charges that will be formed in A and B? Please make an attempt. Make an attempt. Make an attempt. I said, what is the charges that will be formed in A and in B? Can somebody help us? If I bring a positively charged body near two neutral bodies, A and B, they are in contact with each other. Can somebody tell me the charges that will be formed in A and B? I say somebody. I didn't say everybody. Somebody. Yeah. Where? A will positive charge. B will be. Can you explain that? Now, explain it now. Please, this mic on Aurora. Hello? Is it working? So that you give it to the, so that everybody will be hearing what you're saying. You need to start training yourself. You need to start training yourself. Nobody will swallow you here. You are not even standing up. You are just, your voice can explain it. Here you say that this will have negative. I say explain it. Can somebody help us out? say what? I'm not hearing what you're saying. You have off this. Hello? 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 You say what? Okay. 2 of them will be negative. You are not sure. All right. All right. Since we don't have somebody said that A will be negative and B will be positive, but she can't explain it. Okay, stand up. You say, Anna, yo. Oh no, Shimle. Okay, Chimde. Anna, yo, oh no, Chimde. Your attention is needed in the administrative block. You say what? Okay. Okay. Because of contact. Correct. He said that based on induction, that A will be negative. And because B is in contact with A, once A is negative, because of the law of charges, then B will be positive. And I say that he is correct. So here we have negative charges here. We have positive charges here. Now, why this body is still here, you remove this one. Why the charging body is here, once you remove B, B automatically becomes positively charged, while A becomes negatively charged. You don't need to add anything at this moment. You don't need to add anything. Just separate the other one. While the charging body is there, separate B, B becomes positively charged, and A becomes negatively charged. Please, if you have question, you ask your question before we move on. Ask your question. If you have a question, I didn't say you should communicate with your neighbor. I say, in a kokonish. I didn't say you should ask your question. Do we have any question? What your face is? Did I know you? Please ask your question. I'm expecting 1 or 2 questions. If you can't stand up, just write it out. Just as our sister wrote her own question here, please write your question. Write your question. Write your question. Write your question. Any question? Write it out. Write it here. You write it out. Write it out now. Write your question out, or else we move into fields. Or else we move into fields. Maybe I'll introduce fields before we end the class. Somebody say, how do I know whether a material is a semiconductor? If the material starts conducting at a high temperature. Please, can you listen? There should be no noise making. There should be no noise making. Yeah? Did I know you? Now, a semiconductor conducts at a high temperature. So any material that conducts at a high temperature definitely is a semiconductor. Now, let me move a little bit a little bit advanced concerning conductor, semiconductor, and insulator. That is what we call the band theory. The band theory is not in any O-level book. In a band theory, every material have 3 points. We have the conduction band, we have the valence band, and we have the forbidden gap. Please listen. The band theory. This is the conduction band. Please stop talking. Now we have the forbidden gap. Now, this explains the 3 materials we have. We call this the band theory. B-A-N-D. The band theory. Now, in a conductor, electrons are found in the valence band. Electrons are located in the valence band. Now, if an electron will jump from the valence band to the conduction band, there will be conduction. So for an electron to move from the valence band and move to the conduction band, there is conduction. So in a conductor, which is the first one, you can see the valence band and the conduction band, they are overlapping with each other. So electrons can move from the valence band to the conduction band easily. Electrons can move from the valence band to the conduction band easily. Now the second diagram is an insulator. Is an insulator. An insulator contains a very big forbidden gap. So it's not possible for an electron to move from the valence band to the conduction band. That's why an insulator cannot conduct electricity. There is no two ways about it. Even if you heat it to a very high temperature, Even if you give the electron energy, once it can jump, it will still fall into the forbidden gap. And so long as the electron cannot reach the conduction band, there is no conduction. So long as the electron cannot move to the conduction band, there is no conduction. Now, in the semiconductor, which is this one, please look up. This is semiconductor. Now, at a normal temperature, if these electrons want to jump from here to here, they will fall inside this place. At a normal temperature. But if the temperature increases to a very high temperature in such a way that the electrons will gain energy, they will now jump from here to here. That's why we say that an insulator conducts electricity at a very high temperature. So when you increase the temperature, you're automatically giving the electrons kinetic energy to jump. So if they attain that kinetic energy, they will now jump over the valence, the forbidden gap into the valence band. And that's why we say that they conduct electricity at a very high temperature. So you see the difference using the band theory. The difference using the band theory. I have some series of questions there. Let me go through those questions. Do you think I can finish all these questions? Wait. First and foremost. Now somebody say, please sir, what is the work of a fuse? The function of a fuse is to protect your device. The function of a fuse. Do you understand? Well, you should know, if you buy any electronic device that don't have a fuse, you are stupid. Do you understand? Because the fuse, will you listen? Just listen. The fuse protects your device. Something like in Nigeria, our current is not steady. So you can have a very high voltage, low voltage. They will bring the light now, they will take it in the next 2 minutes. The only thing that can safeguard your gadget, that's your television set, your DVD, every set you are having is a fuse. So that when the current goes so high, above the 240 volts you are using, the fuse will melt, thereby protecting your device. Without the fuse, your television will burn. In my days have gone, Madam Anosike na the NEPA burn with television. I didn't put those things. I didn't put it because what will happen is that, like the modern fuse we have now, the modern fuse we have now is thermostat. It's not even fuse. Do you understand? If the current goes so high, the thermostat will cut. Your television are about a standby mode. Do you understand? It will rock now. People are that busy. They have your television. We don't say such a thing now. Even the television are about the standby mode. The thermostat will move it to the standby mode, thereby protecting the television. Anytime you now switch it on, either with your remote or, do you understand, from the body. So that's the function. The main function of a fuse is to protect the gadgets. He said, can a body be charged negatively or only positively? You can charge a body negatively. If you want to charge a body negatively, the first thing you do is to bring a positively charged body near it. A body can be charged negatively or positively. Now, you know you can give birth to a beautiful baby girl or a bouncing baby boy. And it's possible that you can still give birth to a boy, but we don't actually know whether he's a boy or a girl. He said, why do we need to eat the gold leaf? Please listen. Listen. These questions are very, very important. He said, why do we need to eat the gold leaf? We need to eat the gold leaf either to remove the electrons or to neutralize the proton. We need to eat the gold leaf. We are eating the gold leaf either to remove the electrons so that the electrons will flow to the ground, or to neutralize the proton so that the electrons will flow from the ground and neutralize the proton. That's the two major reasons why we ate the gold leaf. He said, in a gold leaf electroscope, can we use induction? Yes, you can use induction, and it is the same method. You can use induction, and it is the same method. Do you have any question? All right. We have fields. Let me introduce phrase and we end the class. Just give me 15 minutes. Now, fields. Fields are not football field. Now, fields are regions around a charged body where forces are exerted. Fields are regions around a charged body where forces are exerted. Now, somebody was asking me that he has been wondering why somebody can see an electric wire and put his hands there. Now, most times you need to reason it out. Within you that this thing will electrocute you. Then you will still go there and put your hands there. And it will still electrocute the person and the person will die. Now, the truth of the matter is that the person did not touch the wire. What the person did is that the individual mistakenly comes into the field of that current. Because once there is a wire carrying current, the wire exerts some level of electric field around it. And you don't know the distance of the field. So if by mistake you come in contact with the field, the wire will attract you to itself. The wire will attract you to itself. So the person I'm a met to the wire, all those better at the field. The wire, the force of attraction in the field will bring you to the wire. You will be struggling, but at that moment, there is nothing you can do because the force is very, very much. Ima our fathers can say in Hambo, a boy of Faros, Ima, Arosiana, Ako, in our village, just in one area, one water. I did a good million one day. Now demons, now they are there. All this superstitious nonsense. That one next day, instead of my house, Jeben at the stream. Now I can offer. I want to see those demons. Why is it that people don't go to that stream on Wednesday? When I get there, and one of them demons not here. Yeah, I can't create my house and outside the stream. Just small boys. They will come there every Wednesday. They will watch the stream. As such, I Hannah. If I say Thursday, we will meet as soon as the more we will start it. Do you understand? Some of these things are superstitious nonsense. But there is force exerted around any charge-carrying body. And that region is called fields. Now we have three types of fields. We have electric field, we have gravitational field, and we have magnetic field. Now, the gravitational field is only the attractive field. Electric and magnetic field are both attractive and repulsive. But the gravitational field creates only a force of attraction. Write it there for your jam question. I said the electric and magnetic field creates both attractive and repulsive force. Electric and magnetic field creates both attractive and repulsive force, but the gravitational field creates only an attractive force. But the gravitational field creates only the attractive force. The electric and magnetic field creates both attractive and repulsive force. The electric and magnetic fields create both attractive and repulsive force, while the gravitational field creates only the attractive force. In our next class, we start from electric field.